This is Dr. Kalpana, belongs to the CSC department. I'm going to discuss about the data structures and algorithms, and let's start the session. So let's start the session with the data structures. Okay, it's a one of the version. It's a queue. We will start with the queue, and the queue is one of the examples of non-primitive data structures. So let's start with the queue. The queue is a data structure in which we are going to insert at one end and we are going to delete at another end. So and queue can also be known as a first in, first out data structure. In a queue, a new element is added to the queue from the one end, that is called as a rear end, and then we are going to delete, always we are going to delete at another end, that is called as a front end. When we delete an element, rear will be incremented by 1. When we delete an element from the queue, then the front will be incremented by 1. So the people standing in a railway reservation row are an example of queue. So whoever enters the first will be relieved first. So that's the reason why it can also be known as first in, first out data structure. So each new person comes and stands at the end of the row, and the person getting the reservation confirmed get out of the row from the front end. So this is actually this is the representation of the queue data structure. So the data can be entered at one end and can be deleted at another end. 10 will be inserted from the rear end first, so it will be entering into the list first. So and next 20 will be entered in the next, and rear will be incremented by 1. Again the 30 will be inserted into the queue, then the rear will be incremented by 1. Again the 40 will be inserted, then it will be inserted after the 40, 30, and rear will be incremented by 1. At the last we entered the 50. So whichever the element inserted first will be ready for the deletion first. So we are going to enter the data elements at rear end, and we are going to delete the data elements from the front end. So that's the reason. So whichever the element is inserted first will be deleted first. That's the reason why it is called as a first in, first out data structure. And so queue can be implemented in two ways. Okay, so we can implement the queues by using the arrays, and this is known as a static implementation. Okay, so we can't. We have to specify the size prior to the word insertion. At the time of creation only, we have to specify the size of the array. So that's the reason we'll be calling it as a static implementation. When coming to the another data structure, that is known as using a pointer, so which can also be known as a dynamic implementation. In the dynamic implementation, so we need not to specify the size of the data structure or the queue, we can say. So dynamically you can insert, you can delete as per the user's requirement. So this is dynamic in nature. So whenever we want to increase the size, we can, and when we want to decrease the size, we can decrease the size. And these are the operations which will be performed on the queue. So let's start with the queue operations. So we have here the NQ operation. NQ operation can also be known as a insertion operation into the queue. NQ is also known as an insertion operation into the queue. So the NQ inserts an element at the end of the queue, that is known as a rear end. When we want to insert an element into the queue, so we have to call the NQ operation. Next we have another next operation that is be performed on the queue is known as a DQ operation. The DQ operation can also be known as a deletion operation. So deletion operation removes or deletes an item from the queue and returns that element from the front end of the queue. So we are inserting elements from the rear end and we are deleting the elements from the front end. So when you want to delete an item from the queue, we have to call DQ operation. So when NQ is called, rear will be incremented by 1. When the DQ is called, the front will be incremented by 1. Next is a front operation. This front operation returns the element at the front end without removing it. When we want to know the status of the queue, so what are the elements, if we want to know at the elements at the front as well as the rear. So if you want to know about the front element without removing it, so we can call this operation, that is called as a front. without removing any element, it returns the, it will reveals what is the element at front end. Next operation is a rear operation. This operation returns the element at the place of rear end and without removing it. When we want to know about the element at the last without removing that element, so we can call the rear end. So it's going to remove the element which is at the last position. So front end will gives the element which is at the front position, and the rear end will gives the element which is at the last position. So it doesn't remove any, without removing any data item, so it's going to return the data. Next we have an operation known as an is-empty operation. So is-empty operation indicates whether the queue is empty or not. So it specifies whether the queue is empty or not. And next we have another operation known as a is-full. It's going to what indicate, so whether the queue is full or not. So last we have an operation known as the size operation. This size operation is going to return the size of the queue, that is the total number of elements a queue is holding. So these are the operations which are performed on the queue. Next we will discuss about the types of the queue. So we have these are the different types of queues we have. The first one is a simple queue, next one is a circular queue, next is priority queue, and the last is a D queue. These are the 4 types of variants of queues. Let's discuss about the next as a list. So list is actually it can also be known as a linear linked list. So it can be defined as a collection of variable number of data items. So we can say it is a dynamic in nature. So which contains the dynamic, which contains the dynamic collection of variables. So whenever we want, we can insert and we can remove. So there we need not to specify the size of the linked list prior to its creation. And the lists are the most commonly used non-primitive data structures. List can also be known as a linked list mostly. An element of the list must contain at least 2 fields, one for storing the data or information, another for storing the address of the next element. List actually is we can say the collection of nodes, where a node is going to hold the data and as well as the address field. So a list will be containing the nodes like this. A node contains the 2 partitions. One partition is going to hold the data, or we can say the information which a user want to store, and another field will be naming it as a pointer field or address field, where it is going to hold the address of the next element. So as you know, for the storing address, we have a special data structure of the list. The address must be pointed type. Next, technically each element is referred to as a node generally. So therefore we can say it's a collection of nodes. So this is actually the representation of a linked list, and so these are the nodes. So these are node 1, node 2, node 3. In the node 1 we have a data field. This is going to hold the data known as A, and another one is the address field. This address field is going to hold the address of the next node. So this is actually the data item, and this is a address field. So address field holding the address of the next node. So this is the second node where it is going to hold the data at the first partition, and the second partition, this is known as address field. Again it's going to hold the address of the next node. So again here we have one more node which is having again 2 partitions. So first partition it's going to store the data, and the next is going to hold the data of another next node, but here we don't have any nodes. That's the reason why we are going to just be storing the null over here. Null indicates that this is the end of the linked list. So here we are going to have again one designated node known as a head. Head is going to hold the address of the first node. This is where the linked list will start at the head node. So head is going to hold the address of the first node. So here we have our types of linked list. We have a single linked list, doubly linked list, the single circular linked list, doubly circular linked list. So these are the variations of the linked list. Thank you.